a little hand up there. Okay. All right, so this is kind of, I think I labeled it 2.2 on the homework, but we could even, this is anything, I'll go right after this. Sections kind of 2.1, 2.2, and 2.3. Does anyone know what velocity is? Okay, yes, what's another word we use? You're exactly right, yeah. What do we sometimes do distance over time is equal to? Speed or rate. All of those are perfect. Speed, rate, velocity. The only difference between speed and velocity, at least kind of how I don't know, a physics teacher, maybe this is too general, but velocity could be negative because it involves direction, okay? Where speed is just always positive. Okay. All right, so velocity is, let's put speed with direction. Let's write a few things down. Rate, we're going to write it like this. Instantaneous, right? Instantaneous rate of change. Who knows why we use that word instantaneous? Because we're finding rate at one point, one specific point in time. So I kind of like that word just because it reminds us, wait, that's not spelled right. Instantaneous. I think it's right. Is it right? All right. I'll look it up. That doesn't look right.
Instantaneous.
Yeah, instantaneous. How about that? Yeah, I think it has to be, hang on. I think it's this. Is that right? Now that looks too long. Is that right? Okay. Okay. All right, maybe we should have left it out. But instantaneous meaning at that one point, okay? But the more specific thing, rate or rate of change, what did we use for the word rate of change? That is our first derivative. That's kind of like slope. We could even put slope here if we want. Rate of change, slope, which is our first derivative. Oh, let's see. I think that'll be okay. So maybe draw a line there. All right, acceleration. Acceleration is your rate of change of your speed or your rate of change of velocity. Rate of change, right? How fast, right? You think of acceleration when you step on the gas, right? And what you're actually doing is it's the rate of change of how fast you're going. How quickly are you changing from one speed to the next? So your rate of change of speed, or we'll say velocity. So does that make sense that it's a rate of change of velocity, that acceleration is your second derivative? It's your derivative of velocity because it's the rate of change of velocity. So this guy is the second derivative. What do you think? Does that make some sense? If we're talking about acceleration deals with the rate of change of your speed, and speed comes from the first derivative, acceleration is your second derivative. We're not going to spend too much time with this one, but I just want you to also know that you can use it in business as well. There is, I don't know if Justin has a business calc or if they do their own thing in their business department, but the first year I was here, I thought maybe we'd have some business majors, but we don't. But there are some schools that make them take calculus because you can involve some derivatives with talking about cost and money. So in that case, we use rate of change. So as soon as we say rate of change, that's a derivative. Rate of change of cost, which is always important, right? Rate of change with cost with respect to items produced. So as you make more items, how does that affect the cost? Okay, and those are some things that you can predict with derivatives. Because you're predicting, what are you predicting? You're predicting a rate. If you're predicting a rate, you can use derivatives. All right. Oh, actually, yeah. All right, so let's try the first one. But main thing, velocity, when you see velocity, we're going to talk about the first derivative. Velocity, first derivative. And then acceleration, that only comes up a little. That'll be the second derivative. All right. A projectile is fired directly upward from the ground with an initial velocity of 112 feet per second. And its distance above the ground after t seconds is given in this formula. So you tell me what's happening at 3 seconds. You plug a 3 in, and that'll tell you how high above the ground it is. This equation is giving us distance above the ground after so many seconds. All right, write the equation to find velocity. What are we going to do? When in doubt in this chapter, velocity, first derivative. Take the derivative. Okay, so we'll write this as S derivative. We're going to take the derivative. And we're taking it of this guy. What's the derivative of 112t? That just goes to 112. And then this guy, roll it down, subtract 1, roll it down when there's a number there, you multiply, so negative 32. So now if you tell me 2 seconds, I can tell you the height and I can tell you the speed or velocity. So this will still tell me the height. This will now tell me the speed or the velocity. All right, okay, so here it is. What is the velocity at 2 seconds? So we, go ahead, who's going to say something? Yeah, beautiful, yeah, good, yeah, don't hesitate, yeah, good. So she says, hey, if I want the velocity, this guy here, I'm trying to think, should we even put like a V for velocity or just remind ourselves that we found velocity up there? So what is the velocity when t is, we can write a t, but we're going to plug in a 2. All right, and so what do we get? 112 minus 64, and you wouldn't have to write that. If you want to just go right to your answer, that's fine. I got 48. Does anyone know the unit? When we first said velocity, you said distance over time. No. Is that, yeah, I think that's what you said. Yeah, distance over time. And that is our units. That's our units, distance over time. So it's going to be feet. Oh, you can even kind of use this guy. Feet per second. And I don't know why in all books, they always, don't let this 112 bother you. They always just tell you the initial velocity, but then it shows up in the equation. So I'm not sure that seems to be a standard. I guess it's something you kind of have to know to write the problem. So that's why they tell you. Okay. All right, and then we do it all again. We could, because they want it at 4 seconds. All right, so 112 minus 32, but this time it's going to be times 4. Our time this time is, we're just plugging in here for t. So that gives us what? 112 minus 128. Which gives us negative. Now don't panic, it's still velocity, it's still rate, so it is still feet per second. And that's the whole reason we don't say speed, because we can't say speed at negative 16. So what is that negative telling us? That is still our velocity. Our velocity is negative. Does anyone know why? Okay. Beautiful. Yeah, and again, we only read the problem once, but we're talking about something going up and then coming down. So at 4 seconds, it has this speed of 16, but it's negative because remember, velocity also gives you direction, which means it's coming down. Okay, so yep, just mark that, coming down. Just a reminder, and you can't see that. Okay. What else? There's one, I don't think I took it off. So there's one on the homework that says find the velocity, 48. Then it also says find the speed. For this one, the speed would also be 48. Okay. What about for this one? For this one, the velocity would be negative 16, but the speed would be 16. I think it's a positive one, so you don't even have to worry about it. If it's positive, velocity and speed, same thing. Okay. Let's go up a little, though we might need that, right? Okay. At what time does it reach its maximum height? What time does it reach its maximum height? So our answer is time, which means we're going to solve for what variable? We're going to solve for t. But now we've got two equations. Our original has t in it, and then also our velocity has t in it. But we're going to have to solve for t. Okay, this, as soon as it asks for what time, we're solving for t. Maximum height, okay, this kind of ties in 2.2. Let's flip this over. What do we know about a maximum height? Yeah, its slope is 0. Its slope is 0, which is the same thing as the derivative. So the maximum height, what do we want to say? Velocity is 0 because it's a horizontal tangent. Velocity is 0, slope is 0, all of that goes together. So that means we're going to use this equation. Velocity equals 112 minus 32t. We could sneak that in maybe over here. I don't know how much room we have. Let's draw that picture and show that that right here is our max. I think we can put that in on so that you have some type of picture too. I think that'll help. Okay, and then we put a 0 in for velocity. So we actually have to put the 0 in over here, and then we have to go solve for t. It's up to you. Do you want to subtract 112 or add 32t? I usually like to keep my variable where it's at, but I kind of like the idea of changing this to a positive, and then we don't have two negatives. So just be careful. (32t equals 112. And so then I'll just rewrite that over here. How do we solve that? Divide by 32. And so t, which is time, beautiful. That's what they asked for. What time? I think it is a decimal. Did we get 3.5? 3.5. I don't take off for units, but it just helps you find, what did we find? I think more than anything, that was time. So my units would be whatever time was measured in feet per second. So this is just time. So this would be the 3.5 seconds. All right, so what do we know about, how are we doing, okay? What are we doing about D? D says, when does it strike the ground? Anytime it's on the ground, its height is what? Its height is 0. Yeah, we usually either like the maximum, because we know the derivative is 0, or we like stuff on the ground, because we know the height is 0. Height equals 0. Now, which formula dealt with height? That was the original. That was S S is for H. Because it doesn't always have to be height. Sometimes they talk about a ball going like back and forth. So they like to use S instead of H, but most of the time we can think of it as the height. All right. So we actually want to go back to this equation. S equals 112t minus 16t squared, because S is the height. So you have to think about what they're giving you. This one was kind of hard because first of all, you had to remember or realize on the ground the height is 0. They give you the height, then we got to go use the height formula. Okay, so height is 0. S, remember, is actually height. Kind of like position. How are we going to solve that? Factor, yes, I heard a couple of you guys say factor, beautiful. I think, if you want to rewrite it, you can. I think 16 does go into 112. So let's take out a 16 and a t. And then we're left with, because this is 0, okay, that's kind of nice. Okay, so what do we do? We're factoring out. So 16 times what gives us 112? 7, beautiful. Okay, good. Minus, and then the only thing left here is t. Okay, so that means, remember this equals 0, so that means either 16t equals 0 or 7 minus t equals 0. How do you solve that first one? Because we took out a variable, we have to at least think about it, okay? So if it was just 16, we wouldn't even care. But 16 can't make the problem 0. But 16t can. If I divide both sides by 16, I get t equals 0. Okay, and then here, we could just add a t. And so t equals 7. What is this t0? A t is time. So that means time is 0. Does it make sense that at the start of the problem, the object was on the ground? Okay. So that's just kind of reinforcing like, hey, I'm probably doing some good things here. Like, because it makes sense that on the ground is when the problem started. Now, I think there's another one where if you punt a ball, you could argue that like, and I think it is in this, like the ball is 2 feet off the ground to start. So they can make it even like more realistic. But in general, this is kind of telling us, hey, it was on the ground at the beginning of the problem. So this is just beginning of problem. Beginning of problem. All right. And so when does it strike the ground? If it actually takes off and then finally comes back and lands, that happens at 7 seconds. So that is the answer then, the 7 seconds. Yeah.
Sorry. Do you only take the derivative of it when you're dealing with velocity?
Yes, exactly. Yeah, right. Good point. Right. They kind of tricked us, didn't they? They asked this question, the 4th question, but it had nothing to do with velocity. Yeah, but they were kind of nice. But yeah, that's going to be the hard part, right? You're going to kind of have to think about what equation you want, right? And there's nothing with velocity there. So we didn't need that velocity formula, but they were setting us up for E. Because look what E asked for. What is the velocity at the moment of impact? So in this problem, I do want velocity. So I'm going to go back to my velocity equation. I do want velocity. And if I want to find velocity, what do I have to have? If I want velocity, so I want to find an answer for V, that means I'm going to have to plug in an answer or a number for T. Well, what was the time at the moment of impact on the ground? That is the 7 seconds. That's why they had us find the 7 seconds. So the 3.5, that was at the height, but they want now the velocity of when it is hitting the ground. It's coming down, so it better be negative. Okay, so let's see what we get. So that's why they had us find the 7. They kind of set us up there. See any of this? So I got negative, let's see the negative 112. So 224, 112 minus 224. And so the negative part is okay because it was coming down. So that looks really good. It's a speed, it's a velocity, so feet per second. Yeah, but good point. D, right, didn't use velocity, but they were setting us up so that we could use it. But yeah, good, right. You're not going to know that, right, if you haven't read E yet. So just take your time, think about, you can use either equation at any time. Good. Okay, let's try. Let's see. All right. Okay, so this one is a position of a particle. So this is actually supposed to kind of be a ball kind of more rolling back and forth. So it's not just up and down. Okay, and that's why it actually can go to a cubic then. It's not just something going up one time and coming down. Okay. So the position of a particle is given by the equation where T is measured in seconds and S is in meters. So how far has it rolled and then coming back and then rolled and then coming back. All right, find velocity at time T. What are we gonna do? Find the derivative, right? Velocity is the rate. The rate is found with the derivative. So we go back to our equation, roll it down, subtract 1. Roll it down, if there's a number there, we multiply. And then the derivative of 9t simply takes us to 9. So if they just say at time t, that means find the general equation. Okay, and then how do we find acceleration? We could even we did find the derivative, but that is also velocity. How do we find acceleration? Take the derivative of velocity, or we could do second derivative like that. So acceleration is the second derivative. Roll it down, subtract 1. So, and when we roll it down, multiply. The negative 12t goes to negative 12, and the 9 goes to 0. Good. Okay, and then find acceleration. We could do this maybe A for acceleration. Find acceleration after 4 seconds. Okay. So this equation up here would kind of give us its location. This would give us its speed, and then this one gives us the acceleration. So this asks find the acceleration after 4 seconds. So acceleration, 6 times 4 minus 12, 24 minus 12. So that would give us 12. If you write 24 minus 12, that's fine. You don't have to, whatever works for you. What are the units? Does anyone know what the units for acceleration are? What are we dealing with? Meters and seconds. It's meters per second squared. Your physics class is paying off, right? Good. Because we want we're involving the time of the rate. Does that make sense? We're involving the time of the rate. So the rate is this guy, and then we still have to involve the time, and that's why second then is squared. All right, find the acceleration when the velocity is 0. Find the acceleration when the velocity is 0. Well, if I want to find acceleration, I have to have time. So I got to put that off for a second. And I have to start by using the velocity formula, because that's what I know. I'm going to use this velocity formula. And why am I using the velocity formula? Because I know my velocity. What am I going to actually put in for v? 0. Okay. So yes, I want acceleration. I had to put that on hold because I need, the only thing I know is velocity is 0. So I got to go back up and use velocity. I get to put in a 0. And there's my nice trinomial. So I got to find t. Because if I have t, then I can go use acceleration formula, right? In fact, I just did that up here. All right, so what are we going to factor? We have a nice trinomial set to 0. Factor. This time I'm only going to take out a number, so I'm not going to care about that 3. So that'll take me down to what? T squared minus 4t plus 3. I don't care about the number because 3 is not going to make the answer 0. There's nothing. If it was 3t, I care about it. I don't care about the number. If you want to divide by 3 and get rid of it, you can. You can't divide by a variable. So we would not divide by 3t and get rid of it. All right. All right. This, let's see. This is factor. If not, we do quadratic formula. I don't think there's anything like that on the test, but keep in mind, it doesn't always have to be nice numbers, but the book is pretty nice about it. Okay, so what multiplies to 3 but adds to be -4? -3. What was it? And -1. So that actually means t minus 3 equals 0. Or t minus 1 equals 0. So that actually means add a 3. So t is 3, add a 1, t is 1. Okay, so now can I find acceleration? Yeah, I just get to do it twice, right? I get to do it when time is 3. Now I go to my acceleration formula. 6 times 3 minus 12. So that gives us what, 6? 18 minus 12, 6. It's acceleration, so it's meters per second squared. And then we do it again when it is, go to make sure you go, are we okay where we're going? We're going to the acceleration formula because our end result is we want to know the acceleration. So now we're going to this guy. Acceleration is 6t minus 12. We could write it if you want to write the formula first, especially in your notes, so you can see where we got that, and then we can plug in the 1. So that gives us -6 meters per second. I just did estimate. Meters per second. Good. You have to be a little careful with what the negative means because you have to know what the velocity is. So if the velocity is going down, then the negative actually goes with it. But if your velocity is positive and your acceleration is negative, then that means you are slowing down. Okay, so in general, I mean, there's a little bit more to this negative, but it definitely involves, you know, you can accelerate up, but you can also then decelerate, right? So there's we're not going to get into that because that takes too long, but a negative for acceleration is also okay. All right. When does a particle reach a velocity of 24 meters per second? Okay, this one just, this one's a little harder. All right, so what are they giving us? They are giving us velocity, and the question is when. So my answer is a time. Okay, so my answer is a time. So that means I'm solving for t. Solve for t. Okay. So don't notice it doesn't take too long to do these problems. So go ahead and sit and kind of think through, because once you get it, it's like 2-3 steps. Okay, so it is okay to kind of think about it. I'll go ahead and underline what you're given. And I know it's easier said than done, because I sat there and, you know, the teacher's always like, underline what you're given, what are you looking for? But you can feel overwhelmed for sure. But it does kind of help if you just sit back and think, because these problems are pretty short. So velocity is what you're given, and when, as soon as it asks for when, it's looking for a time. Okay. All right, so I'm going to take my velocity formula, 3t squared minus 12t plus 9. Did we see that that was in A? Okay, that's a formula for velocity, that's A. Where do I put in the 24? I put that in for the velocity. They gave us velocity of 24, and I said I wanted to solve for t anyways, so I want to leave that open. Now, just be careful. What do I have to do before I factor? Say that again? Yes, but there's something I have to do before that. But you're right, we are going to do that. But what do I have to do before that? It has to equal 0. It has to equal 0 first. And this is the first time where it equals 24. It doesn't equal 0. So before you start factoring and everything like that, you have to subtract 24 and make one side 0. We pause for a second. So notice on that one, that was the first time where we weren't plugging in a 0. So if you plug in another number, that's fine, but you got to get everything to one side and let it equal 0. Questions on that? So don't forget that. Well, before you start factoring, I know we're all excited to factor, right? But before we factor, one side has to be 0. All right, now though, and thank goodness we still can take out a 3. Absolutely take out that greatest common factor. T squared minus 4t minus 5. All right, so now the 3 we don't care about. All right, so t, now we're good to go. Just make sure that one side is 0 first. Now what multiplies to -5 but adds to be -4? So that's going to be what? -5, +1. So that makes t equal to 5 or -1. Now, velocity can be negative, acceleration can be negative, time cannot be negative. Okay, we can't go back in time. So, but that's okay. That doesn't mean we did anything wrong. It just means that our equation doesn't fit our whole situation. That happens a lot. So this, we just don't care about. This does not fit our problem. And that's okay. Don't panic if you get that. This covers the entire parabola. Our situation does not have to be the entire parabola. We're going to always start at time is 0. And so that's fine. This just doesn't occur. So it is then 5 seconds. So for time, don't panic if you get a negative. It's just that part of the parabola or that part of whatever your formula would produce. We don't care about. All right. When is, that's it. So we did it. All right. That wasn't too bad. When is acceleration 0? When? What's our answer going to be? Time. When? We're going to solve for t. Solve for t. And they give us acceleration, so we're going to use that acceleration formula. So go back up to B. That I'm just getting from step B. If you look, I could slide it down. That should just be coming from here. Acceleration. And we know acceleration is 0. So we put in a 0 for A for acceleration. Added. This one, maybe I'll add a 12. Added 12. Divide by 6. Two. When? So my answer is time. So 2 seconds. I was thinking, I think I just got this from the book. I'm not sure, but they really should have put units on that. 0 could be anything. All right. I'll have to go back and look. All right, we're not going to get to 4, so let's just see if we can get through 3, though. 4, yeah, I never have time for 4. That's okay, but I want you to at least see that's the business one, just so that you at least, you know, even if we just glance at it, and they're talking about marginal cost. So that's more the business one. We'll stick to this guy. All right. Anything super tricky? What is, okay, this one maybe is a little bit harder. Okay, football is being punted. Its displacement above the ground, so how high above the ground is in feet, is given by this formula. And T is in seconds. Okay? And that's actually this 2. This 2 is actually when time is 0. And that's what I was talking about. In this case, it's not on the ground, right? But when they are punting, it is, a kickoff would be on the ground. A punt is technically a little bit higher. So that's what that 2 is representing. But again, sometimes it could be on the ground, but in this case, it is a little bit higher. Okay, what is the maximum height reached by the ball? So maximum height is this formula. This formula right here. But in order to use that formula, I need time. Okay? I want the answer right here. This is height. This is height. That's what I want for an answer. But in order to use that formula, I need T. And I have nothing about T. But what do we know about the maximum height? We know the derivative, the slope, however you want to say it, is 0. So whether they tell me or not in this problem, I have to go find the derivative. Because at the maximum height, I know that the velocity is 0. Maximum height, I know that the velocity is 0. Okay, so I need the derivative. Because if I not want something about, can I sneak a V in here now? Don't forget, velocity is going to go with derivative. So this one's kind of hard because they're asking us to use this equation, but we have to put it on hold for them at that formula. All right, so what is the derivative? Roll it down, subtract 1, so negative 32t. 40t goes to 40, and 2 goes away. Okay. All right, now I know the velocity is 0. I know velocity is 0, and I can go find time. Oh, let's see, should we add 32t? (32t = 40). I don't think this is a great one. Well, it's not too bad. So if we divide, what do we have to divide by? Divide by 32. And so t is it 1.25? That's not too bad. Now, can we see? Okay. All along I said I needed to use this formula for the height. Now can I go use that formula? Yes, because I need a t value, which I just have. I'm going to plug in 1.25. Okay, so now I can finally find my height. I'm going to put h, even though it's represented by d of t, as negative 16 1.25 squared plus 40 times 1.25 plus 2. So sure enough, I did use that formula, but I had to kind of put it on hold. I had to go find t. But as soon as they tell you something about maximum height, you know you're probably going to have to use velocity. All right, and this gives us, it should give us 27 maximum height. So it is feet, which is not very high. Bear should sign them up, right? Those are the kind of kickers we like. All right. All right, let's try this last one. What is the velocity of the ball when it is 18 feet above the ground on the way up and then on the way down? Does that at least make sense? That if we're talking about height and we're talking, now this, we are talking about a ball going up and then down, it is going to be at a height 2 times. Once on the way up and once on the way down. We're looking for velocity, but they give us same, it's almost the reverse. We're looking for velocity, but they're giving us a height. If they give us a height, we have to go use that equation. So we're going to have to use that height equation. It's the exact reverse. We're going to have to put stuff on hold. If they give us height, we got to go use that first. But what comes out of the height is a time. And can I plug the time in to find the velocity? Perfect. Okay. Does that have to at least make some sense? I'm going to start and find velocity, but I'm going to get time. Then I can take that time and put it into my velocity. All right, so height is 18. I want to at least do this part because I have my nice trinomial, but what do I have to do first? Got to get it equal to 0. So you have to subtract that height. When it's 18 feet above the ground, that's your height. So that has to go in for h. That's not time, right? So you have to subtract that 18 first. Before you go and factor, make sure that you move that 18 over. If it's not 0, if it's 0, if we're talking about a height of 0, boom, we're going right at it. But if it's any other height, then we got to move that over first. Now, and I think I did this because I think this is what it's like on the homework. 16 doesn't go into 40. So this is the long factoring one. So it'll be good to factor again. But if that first one is negative, we definitely want to take out a -8. Okay? So change every sign. So it's going to be at least a positive 2t squared. The 40 is going to actually then be negative because we're taking out a -8. So negative, and then it'll actually, because we're taking out the 8, it'll go down to 5. But do you see how that's negative there? You take out a negative, every sign changes. So then this becomes plus, and then 8 goes into 16 2 times. I took out a -8. I only took out a number, so I don't care about him. But I do have to do the long process. What multiplies to 4, but adds to be -5? But it does work, right? -4 and -1. That'll multiply to 4, but add to be -5. Now remember, that doesn't go into your parenthesis. You've got to do 2t squared, and then instead of this guy, you use these guys. -4t minus 1t plus 2. Remember, you use these guys into the middle. You split up 5 with those. All right, then what do the first two have in common? You can take out a 2 and a t. And so you're left with t minus 2. What are you going to take out of these two? Someone said it. -1. Take out a -1 so that you're left with then a positive t. As soon as you take out a negative, everything changes sign. So that goes to the -2 then. And so now we're in good shape. Now we're actually going to take out t minus 2. And we're going to be left with what's in front here, 2t minus 1. I know that is the harder one to factor for sure. So at least try your best. If you need help factoring that, let me know. We can look at that tomorrow real quick or next couple days. All right, if you get everything and you just need trouble there. All right, so now here, t minus 2 has to equal 0. Well, that's no problem. Just add 2. What about this one? 2t minus 1 equals 0. So here you actually have to add 1 and then divide by 2. So add 1 and then divide by 2. Now, I'm circling, maybe I shouldn't have, but so there's 2 times, right? And that makes sense because we already talked about 1 on the way up, 1 on the way down. What was the question though? I can't remember, so long ago. What is the velocity? What is the velocity? So now I can go use the velocity formula. Velocity was -32t plus 40. Velocity formula, okay? So now I can plug the 2 in, and then I can plug in a 0.5 if you want, however you want to do it. So -32 times 2 plus 40, and then -32 times 1/2 or 0.5 plus 40. But they said it was going to happen 2 times anyways. Let's see. So which one? This one. Well, does that make sense? Which of these times should the ball be going up? It's got to be the smaller time, right? Because first it goes up and then it comes down. So the first time, the 1/2 better give me the positive, and in fact it does. It gives me 24 feet per second. And then this one actually gives me the -24 feet per second. But that actually makes sense because my smaller time, it traditionally goes up, right, and then down. There could be some situations where you drop something, but in this case, it's going to go up first. So my smaller time should give me the positive. They're going the same speed, but what's the negative telling me? It's on the way down. Okay, they're going the same speed, but the negative is telling me it's on the way down. All right, so give those a try. Like I said, at least try to process it. Try your best, see how you do. You'll be fine. There's a lot in this chapter, so on the test, it's going to basically be find velocity. Okay, so, but the more you can practice and get ready for it, the better. All right, back to rules tomorrow.